Question 5 students about the case study. Amruta stood near the base of a lighthouse. Gazing up at its towering height, she measured the angle of elevation to the top and found it to be 60 degrees. Then she climbed a nearby observation deck 40 meters higher than her original position and noticed the angle of elevation to the top of the lighthouse to be 45 degree. So now here students, from the given information, first we draw the figure. So here consider that AE is the ground level, and E is the base of the lighthouse. So we have considered that this CE is the height of the lighthouse, and this A is the position of the Amruta. Amruta stood at the position A, and then she observed the top of the lighthouse. Top of the lighthouse is C, at position C. So Amruta observed the top of the lighthouse here and making the angle of elevation which is equal to 60 degree. So the angle CAE is equal to angle of elevation which is equal to 60 degree. Then afterwards, Amruta stood on the observing deck. This is the observation deck, and which is of the height 40 meter. And then the Amruta's position will be at the point B. Then the position of the Amruta becomes at point B. And then from that point, the Amruta observed again the top of the lighthouse. And then Amruta observed from B to C and making an angle 45 degree. So here this angle is 45 degree. This angle is angle of elevation. So angle CBD. Angle CBD is an angle of elevation which is equal to 45 degree, students. So here, this from the given information, we draw the figure. Now here students, we join the BD, this point BD, which is at the height of 40 meter. Okay, that is the DE becomes the 40 meter. Okay, and we consider that the CD is above the observation deck, that is considered H. So such a way we draw the figure, and from the given information, based on the given information, we solve the examples. Based on the above given information, answer the following question. First question is, if CD is H meters, find the distance BD in terms of H. Now here students, we have to find the distance BD. And CD is H meter. So now here the BD and CD, with respect to the BD and CD, the ratio becomes the tan. We use here ratio, the tan ratio, because here the angle made by the side BD is 45 degree. So here we can use the tan. Ratio. But in which triangle? The triangle which is CBD. So here I write in right angle triangle BDC. By using that tan ratio, that is the tan 45 degree is equal to opposite side of angle 45 degree divided by adjacent side of angle 45 degree. So now tan 45 is equal to what, student? Opposite side of angle 45, that is equal to CD, and the adjacent side of angle 45 degree is the BD. So now here students, the BD is equal to CD, and the BD which is equal to the CD, the measure of the CD is H. So here H. So that means students, the BD is equal to H. Okay, the distance BD in terms of h, that is equal to h. Second question, students, finding distance BC in terms of h. Finding BC in terms of h. So here we have to find out the BC with respect to the h. So now here we use the BC included in the triangle BCD. So we also here use that right angle triangle in right angle triangle BDC. So now here that we use here tan 45 no. Here that is respect to BC. Na? So that means here sin 45. So we use the sine ratio here, students, because opposite side upon the hypotenuse. This is the h. With respect to h means it will be, the h will be the opposite side of angle 45 degree. So the opposite side upon hypotenuse, it will be the sine ratio. So here I write opposite side of angle 45 degree divided by hypotenuse. So here now, students, the sin 45 that is equal to 1 upon root 2 and the opposite side of angle 45 which is equal to CD and the hypotenuse that is the BC. So here, students, that is the BC cross multiplying root 2 multiply CD. So now here the BC is equal to root 2 and multiply, that is the CD. CD means the H. So this is the BC, root 2H. A question, finding the height CE of the lighthouse. Use root 3 is equal to 1.73. Okay, student. So here, students, we have to find out the height CE. That means we have to calculate the CE here, height of the lighthouse. So now here, that height of the lighthouse included in this right angle triangle CEA, in the right angle triangle CEA. So here we use that in right angle triangle, CEA, and here we use the tan ratio. Students, here we use the tan ratio. Okay, why we use the tan ratio? Because we have the opposite side, or we have to calculate the opposite side, and we have the adjacent side. That is here BD. BD is the H, students, H meter. So that's why here the A is also the H meter. So here we use the tan ratio. So student, now here that here I write tan 60 is equal to opposite side of angle 60 degree divided by adjacent side of angle 60 degree. So now here that opposite side of angle 60 degree, students, that is the CE, and the adjacent side of angle 60 degree, that is the AE, students, and here tan 60, that is the root 3. Okay, so now here root 3 is equal to CE. We write the CE as H plus 40. So here I write H plus 40. And then AE, that AE is the H. So I write here H. Then simplify here, root 3H is equal to H plus 40. So that means, students, that root 3H minus H is equal to 40. So now here H becomes common. So root 3 minus 1 is equal to 40. So that means, students, here that H is equal to 40 upon root 3 minus 1. So now H is equal to, here we can directly substitute the 1.73 here, or we can do the rationalization process, student. So I do the rationalization process, that root 3 minus 1 here. So I multiply and divide root 3 plus 1. Because it is the simplest way. Okay? It is the easiest method. So here 40 root 3 plus 1, and then here root 3 whole bracket square minus 1 whole bracket square. So here, students, 40, that root 3 now I substitute the value of root 3, that is 1.73, and here root 3 square, that means 3, and here minus 1. So now here students, that is equal to 40 and then multiply, that is a 2.73 divided by 2. So that means the 20 multiply 2.73. Okay, 2 multiply 2.73. Now here very easy, that is a 0, then here the 6, then 14, then 50. So here 54.60 meter, that means the h is equal to 54.60 meter. Okay, h is equal to 54.60 meter. Then now here we have to calculate the height of the lighthouse, that is the CE. So here height of lighthouse CE, which is equal to, that is 54.60 plus 40. Then that means here the 94.60 meter. The height of lighthouse CE is equal to 94.60 meter. Question 3rd B. Finding distance AE if AC is equal to 100 meter. So now here student, observe the figure, where is the AE? AE is this one, and the AC, that AC is 100 meter, that is the hypotenuse is the 100 meter, and these both sides are in the right angle triangle AEC. So here students, we use the right angle triangle AEC. So I write here in right angle triangle AEC. So now here students, we use the cos ratio because we have the opposite side and the adjacent side and the hypotenuse. So here adjacent side of angle 60 degree upon hypotenuse. So now here cos 60, that means 1 upon 2. Adjacent side of angle 60, that is the AE, and the hypotenuse, that is the AC. So now here that means AC upon 2 is equal to AE, and that means the 100 upon 2 is equal to AE. So that means 50 is equal to AE. So that means here students, AE is equal to 50 meter. Okay. So here find the distance AE is equal to 50